Hi Spring fans, in this installment of Spring Tips, we're going to look at how to test REST APIs, microservices in effect. First of all, we're going to build a new service. So I'm going to build a service that's going to be called the customer service. We'll use Spring support for building web applications. We'll use JPA and H2. We'll use the verifier, the Spring Cloud Contract verifier. And of course, just to make my chore a little easier, we're going to use Lombok, which is a compile time annotation processor. We'll then generate a new project, which we can open up in our IDE. So I'll do that now. Unzip customer service, cd customer service, Nautilus, open this up. Alright, so now we have a new application, and our application, we should write the test first, right? Keeping in good test-driven practice, we should write the test first. So let's say that we have a new API, and we're going to call this the customer REST controller test. All right. So this is a new test. We're going to use the Spring Boot test framework. We're going to run with the Spring Runner. Right. This is the Spring Runner that works with JUnit 4 and 5. This is going to be a Spring Boot test that will work with a mock web environment. So we'll say mock, and I think that's it. For now, that'll be okay. We want to use the mock MVC support in Spring Boot, so we'll use that as well. And that'll allow us to auto-wire a mock MVC client here. And the mock MVC client we can actually work with to issue requests against the database. So we'll say public void should return all customers. So we're going to have an endpoint here that we think will return all customer data, right? So we can say this dot mock MVC dot perform mock MVC result matchers dot request matchers, mock MVC request matchers, builders dot get, and we're going to say we make a post to the make a get to the get customers endpoint, and we're going to accept. We're going to send a content type. Well, we don't actually care, so that's fine. We're going to expect certain things back, right? So we're going to say mock MVC result matchers dot status will be okay, no problem. And we're going to expect that the content type will be well known. It'll be a media type, application JSON UTF-8, for example. And what else do we want to say? We want to say that this throws an exception. That'll solve this. And I think we should also, have a discussion about what the shape of the payload should be when it comes back. So we're going to say that we expect the payloads to match a JSON path. So we're going to say mock MVC result matchers dot content dot JSON path, and then we can even use a JSON matcher. We can say JSON path like this, and that's what we're going to do. So we're going to say at let's say the first record dot what are we going to say? We're going to say ID equals 1, right? We'll say equals 1, and equals dot is not empty value, there we go, 1. And we can also say that the first name, or maybe the let's just say name, okay? So the name will be equal to Bob, okay, or Jane. There we go, nice and good. So we have a name there, and we have now we've asserted some basic things about the structure. We're assuming that this syntax here means look into the JSON that comes back. It's going to be an array. This means traverse all the arrays and run a predicate. We're going to dereference the first element that comes back in the array, and we're going to assert that the first record should be Jane, and that the content that comes back will be of type application JSON. So let's run this code. Let's see what we get. Okay, so run, and of course this is going to fail pretty catastrophically. We've written more tests than we need to get to that point, but we do know that this is going to fail. So now it's our job to implement the production code, make sure that this kind of works, right? And normally in test-driven development, you should only write a single test. It returns okay, and then you go back to the production code and you make it return okay, and then it says okay, I'm going to return JSON, application JSON. Then you make sure that returns as you expect, and you go back and forth. But let me just skip ahead here a little bit. I'm going to write the test for one sort of what I expect to be the minimum sort of feature set for this endpoint. So let's go back now to the customer REST controller, which we don't have, right? So we're going to have to go back to our code. We'll go here and we'll say source main Java example customer service, insert customer REST controller, and we'll insert the REST controller like so. We'll say at REST controller, and we'll have some endpoints here. We're going to say that we're going to have an endpoint that returns customers. It's going to return a collection of customer records we expect. So there's that. And already we've gotten into some trouble. We need some customer data, right? So we can say get all customers. We need a customer record. So let's assume that this is a JPA entity. It'll have a primary key, long ID at generated value, and it'll have a string, right? And what did we say in the test? The test looks for name. That's our name. Okay, so we're going to expect that to be there. String name. All right, so there we go. There's our basic entity. Now, of course, this requires getters and setters, so I'll use Lombok to create that for me. And there we are. Okay, so we've now got two entities here, and now we can implement this. Now we know that we're going to need to be able to persist data into the database, so we should use Spring Data JPA here. We're going to create a Java class, a customer repository. All right, and this is actually not a class. It's going to be an interface, and the interface, well, that's enough. That's actually enough to get what we want. So now we can inject that repository here, private final customer repository, and dereference that from the constructor, and then return this dot customer repository that find all. Right, so we have to actually extend JPA repository for this to work. All right, very good. So very basic interface there, and this makes it so that we have declarative data management functionality provided out of the box thanks to Spring Data JPA, which means that we can go back to our test here, the test, and let's see what happens. And of course, this is going to fail as well. First of all, assuming it works, right? I think it should work, but yeah, basically, we expected a certain set of data to be in the results, and of course there is no data. So what we need to do is to mock out the data access layer, which makes sense. What we're trying to test here in this layer is our interaction with, not with the database, but with the REST endpoint. We're trying to assert that given a request of a certain shape that we get a response of a certain shape back. So let's use the Spring Boot test framework's support for mock beans. Basically, we can inject the customer repository, but of course Spring Boot already sees that we have a real customer repository. So what this mock bean annotation says is prepare a mock object using Mockito, and then let the client, that's us, the tester, let us prepare a mock object in our test, and then replace any pointers to this this repository in the application context with the mock version that we're going to configure here, right? So let's configure it so that it's not just a mock; it's actually a stub. It'll return certain data when asked. It's going to follow our protocol. So this customer repository at find all, then return, and we're going to return an array list of customers, right? So new customer. The first one will be Jane. Second one will be Bob. And there we go. Okay, so we've got some records in the results that come back. Now, we have, we haven't had to do a lot of extra work here, right? Spring is just smart enough to know to replace the real thing with this mock version for the specific purposes of this test, and that seems to have worked. So we've got, it's working as we expect. We can also prove a negative by tampering with the test here. We can prove that the test was working by breaking the test, just in case, you never know. So that is working as we expect. So good. So we're now in a good situation. Now we've got a service. Let's go build the client. Let's go build a client to talk to this service. All right. So we're going to build a new client here at start.spring.io. I'm going to call this customer client. And in this case, we don't need the JPA support, nor do we need the H2 support, but we can use the stub runner here. So we use Spring Cloud Contracts stub runner. And otherwise, it looks fine to me. So we'll generate that, and that'll give us a new project. So we'll go to our downloads directory, unzip this, extract the files. Okay, customer client, open that up, and open this up. And now the customer client is going to be the client API that others can use to talk that service. We can have a lot of discussions about how much magic should there be in the code for that and all that. But for our purposes, let's just build a simple client and make sure that there's no magic in it, and that the service itself stands on its own, and other languages and other protocols can use it with impunity. But for our purposes, let's just do that. We'll write some code here to make it as simple as possible, right? So we have a package as usual, and we'll build a customer client object. Okay, and in the client object, we know that we're going to have a test. So let's go test this. We're going to create a new test here for the customer client test, and we'll have IntelliJ help us with that, right? Synchronizing our code there. And so in the test, we're going to use the same mechanisms as before. It's going to be a Spring Boot test. We're going to run it with the Spring Runner.class. This is going to use the customer client application, though hopefully for most of your clients you use auto configuration so that Spring Boot consumers can just add the library to the class path and the bean will get registered in the application context. But for our purposes, let's say that we've just got a manual pointer to an application context somewhere and we've got a configuration class. So I'm going to define a test that tests our interaction with the customer service. Okay, client should return. There we are. So throws exception, and in the code we're going to need the customer client. So let's inject that here, of course, private customer client. All right, not bad. So now we say bdd assertions dot then this dot client dot what, right? Where's the method? Get all customers. Well, that's not going to work. So the first thing we need to do is to create that method, right? Get all customers, and we're going to return a collection of what? Customer, right? We need a customer as well. So we need to create that DTO, that representation there. Let's just create it in line. All right, and we can say at data, and we'll give it a, we know it's a long ID and a private string surname. All right, so there we go. There's our DTO, and in order for this to work, we can return a new array list just for now, just to see how much of the test we can get to pass. There we go. So now it's back to working. Then we can say that the size is equal to 2. So let's say that there's 2 records coming back, okay? Let's see if that works. Well, of course that didn't work, right? Several reasons. First of all, this application, this web application, is just that. It's a web application. So we need to make sure it doesn't start up on port 8081 as well. And the other thing is, we don't have this bean configured anywhere, right? This is not registered in the application context. It's not a component, so we need to have that in the configuration here. So we can go here, create a new customer client configuration, customer client configuration, and we'll move the customer out to its own type as well. There we are. Customer client configuration will live here, and we'll register the customer client, right? All right, so return new customer client. Very good. And now we've got a simple service. Let's now try that customer client code again. Will the test work this time? Somehow I doubt it, but we can try. Okay, that failed again, right? And this time it's failing for more reasonable reasons. We're returning 0, but it's expecting 2. So now we need to actually implement enough meat of this test, of this client rather, so that we can get what we're trying to get done, right? We need the REST template, so we can make a call, right? So there we go. We'll inject that into the code base, and of course this implies that we're going to need a configuration for that REST template. So let's create that here. We'll say @bean REST template, returning new REST template like so. And we'll inject the REST template there, REST template RT. There we are, now we're cooking. So now we have a REST template, and we have the customer client, and the client test is going to return some data based on a call to a web service. So let's write that code here. Instead of returning an empty array list, we can say this.resttemplate.exchange http localhost 8080/customers, right? So we know that's going to be an HTTP GET call. We know that we're not going to send any data to the service And we know that we need to tell the REST template what kind of data we want back. So we're going to say we want a collection of customer data, right? PTR equals new parameterized type reference of type collection of customer. Okay, so now that super type token implementation gives us everything we need to then return the data back. So we can put that in here and dereference the response. So we'll get a response entity with a payload of type collection of customer, and then we can then dereference the body, which is here, and we're off, right? We've got the payload and everything, we're good. Now there's some discussion, there's some argument to be made that we could be using feign or something more succinct in this case, but for our purposes, it suffices to leave things as they are. So now we've got an actual service, and we can try this. All right, let's see. One more time. We've got an actual client, rather. We can try this now. All right, that failed yet again. And I think you can guess why. There's no service, right? And this is actually the problem, if you will, with microservices. In order for us to test this effectively, in order for us to effectively test the boundary of this client, rather, I need to have the API. So, okay, right, I don't want to actually stand up all my APIs each time I want to run tests. That would mean that all of my unit tests now become integration tests when I move to the world of microservices. That sounds like a non-starter, because I'd very quickly end up in a situation where I have to wait 20, 30 minutes just to deploy and just to integrate my simple client, right? That's a non-starter, and it gets even worse if you talk about the poor HTML5 and iPhone and Android developers who would have to, in theory, deploy the whole system just to be able to test the code that they're writing for the client experiences, right? So we need to synthesize that API. This is, we can't expect every client of every service to run every other service and all the dependent services just to be able to go through the continuous integration environment. Remember, the whole point of microservices is to optimize for agility, to gain the speed of change. And if we lose that by giving up our ability to quickly test and get fast feedback, then what's the point? Exactly, right? We want to make sure we have that fast feedback. So, okay, let's mock out the API. And here we can take advantage in the customer client test of WireMock, right? We can auto-configure WireMock. This is part of Spring Cloud Contract. And this is great for APIs that we don't control, right? If we know it's an API that's stable and we don't have the ability to control that service, then we can use WireMock to build a fake API for us. So we're going to say WireMock stub4 WireMock.url equal to WireMock.get. Okay, WireMock URL equals to customers, and what else did we say the client needs? The client needs HTTP get customers. It's on port 8081. Let's make it on 8081. We know the service will be on 8081, so we're going to configure WireMock to start on port 8081. Okay, there we are. And what else do we need? We know that the payload that comes back will be a collection of customers as JSON, right? So our customer client is using the REST template, and the REST template is going to convert the data into a collection of customer entities of type JSON, so ID and surname. All right. So let's try this. We're going to now return a response, WireMock.aResponse, and the response will have a body. It'll have a status code of type 200 naturally, because it's going to be great, and we're going to have a body. And now we could pass in a byte array, we can pass in a string, and this is where it becomes very useful to have the support for testing JSON inside of a Spring test framework, Spring Boot test framework. Here we can inject a object mapper and use that to great effect to just get some JSON for some customer records. Okay, so customers. Okay, so what we're going to do is we're going to create an array list, arrays.asList for these customers, and turn that into JSON using this .object mapper .write value as string, customer list, etc. And this, of course, throws an exception, so we'll say throw exception. Very good. So there's our customer list, and we're just going to use that custom method there to return the data. So the body will be JSON for customer, and we're going to return 2 customers. We know that we're expecting, what did we say? We're expecting well, we've only got 2 records, right? It only says we need two customers. So let's say we've got 2 customers. I think we need a constructor for this to be kind of fun. So all argument constructor, no argument constructor, very good. And we're going to pass in a ID 1, and the first name will be Jane, and the second one will be Bob. Okay, so there's our 2 records. And what else do we need? We need to, I think that's it. I think that's actually, oh, we probably need a content type, right? So with header, HTTP headers dot content type media type equals application JSON UTF-8 value, and that should be it. That should be a very simple interaction. We should have 2 records. If we run the test again, everything should be golden and green, right? Very good. So now let's be a little bit more demanding. Let's make sure we're marshalling data back and forth correctly. So let's say that the data, we're going to store this in a collection. First of all, we'll dereference it and use it as a variable. So customers, there we go. And now we're going to say collection, I'm going to say customers dot iterator dot next dot get ID equals 1L, right? And we're going to say the first one will be Jane. Right, so you can see that we've got these very convenient AssertJ APIs, these fluent tests. So that's been very convenient here because I'm exploring the API, exploring the tests. I just hit control space and the tests basically write themselves. All right, looks like things are working as we expect, right? And so we know that there's 2 records. We know that the first one has the data that we expect it to, so I have no reason to doubt that the second one wouldn't also have that. Okay, so very good. So now we have a client and a service, and might be enough, might be enough. WireMock certainly helps us here. If it's if that API stays stable, then this won't be a big problem, will it? Because we can just use this WireMock stub, and we know that we got it right this time. So as long as it doesn't change, everything will be okay. The trouble, of course, is that that APIs will change. They'll change a lot, and when they do change, we run the risk of this no longer being valid. And additionally, the producer may not know that they've broken the experience that certain customers, or clients rather, have started to become accustomed to, that they started to expect. So they will happily, merrily evolve their service and perhaps unnecessarily and accidentally break the interactions that clients have. So this is not ideal for either side. If there's, what we need is some way to sort of catalog that scenario, that interaction, and ensure that both sides agree on the definition of that interaction, that scenario. And this is what consumer-driven contract testing, or contracts, give us, right? We have a project in the Spring portfolio called Spring Cloud Contract. Spring Cloud Contract gives us the ability to describe a scenario. This is not a schema. Let's be very clear about that. This is actually a sort of documentation of how one client expects to interact with our service. So let's go back to our service here, and we've got this test that we've written, and this test asserts how we expect the structure of the response to look, from the producer side. But again, we run the risk of this drifting out of sync with what clients actually expect. So let's let's capture what we expect to happen in a given test, in a given interaction today, right now, right? So we're going to use a directory here. We're going to say test resources contracts, and we'll create a new contract, which is just a Groovy DSL. So it should return all customers.groovy, and this is a type safe DSL. So we're going to say contract.make, and we're going to provide a description. Should return all customers. Request is going to have a certain shape, so we'll describe that here, and the response will have a certain shape. So now, just to give you a little bit of a prelude, a little bit of foreshadowing here, what we're doing is we're saying that down the line, we want a test to be generated for us automatically based on what's in the contents of this Groovy DSL. And that test will be run against our API in the same way that our actual test, the one that we just toiled over a few minutes ago, does right now. So that test is going to capture all the same things, right? It's going to capture how we expect one interaction to work. So we're saying that we expect a request that goes to the / customers endpoint of type get that has a certain, it could have a certain collection of headers. We expect that kind of request to yield a response that looks like this. It's going to have a status of type 200. It'll have a header, maybe of content type, right? So we can say headers, header, HTTP headers.content type, media type equals application JSON UTF value, and the body will be either a map, JSON, a map that can be turned into a JSON structure. It'll be literally an object value that we can produce back, a list, almost any number of different things. You can even return just a string, but in our case, I'm okay with just returning a collection of maps, right? So that's what the syntax here is. Well, actually, this is a list, but what we're doing is we're creating a map. We're creating a list of objects, dynamic maps. So we can use the groovy syntax here. We're going to say ID 1L, and then surname, or name, is it? Let's see what we have here. Name. So we go to the code. It'll be called name, and the first one will be called Jane. And then we'll create another record, ID 2, and name is equal to Bob. All right. So returning this data. This is not actual data. It's data that we're expecting for our test, right? And that implies that we're going to need to do the same sort of work as we did before to mock out the data access repository, because this is going to actually call our REST API in the same way that we have done before with the mock MVC client, right? So we need to make sure that this mock interaction is captured, right? We need to set this up somewhere. So let's go configure the build process to respect these contracts and treat them as tests, indeed to generate tests from them. And this mechanism is why we say this is a contract, because the contract is kept by enforcing on compile, on build, that the API works as expected, right? We can't install or deploy our service if these contracts aren't passing. And similarly, clients won't be able to consume the definitions of the contract if they haven't been able to deploy it and install it. So we're going to use a build plugin here called the Spring Cloud Contract plugin, right? So here we go. Spring Cloud. I suppose we need the group ID first. So org Spring Framework Cloud, Spring Cloud Contract Maven plugin. And we need a version. We can say 1.1.1 release. That's fine. And this has a few other bits of configuration. The first thing that we have to do is configure that it works with extensions, sure. And the other thing that we need to do is to give it an idea of where to find a base class. And when I say base class, what I mean is we need some class that this dynamically generated tests, these dynamically generated tests that we're going to create will extend, right? So we need some sort of base class that it can extend and in which we can do any kind of sort of test setup. So let's create a base class for tests, and we'll create a new base class here. Java base class. Here we go. So this is our base class, and we'll revisit this in a second, but let's make sure we finish our thought here. So com.example.customerservice.base class. All right, so we've got that in place. Now we need to actually implement that base class. That base class will be a Spring Boot test. It'll be run with the Spring Runner, right? So we're going to use that, and we're going to auto configure mock MVC. That's fine. Actually, I don't think we even need to do that. We do have to do some setup though, don't we? We need to set up the rest assured testing, right? We're not using standard the tests themselves don't use the standard mock MVC, Spring MVC apparatus. They use the integration with rest assured, so it's not hard to set up. We just need to say rest assured mock MVC standalone setup. You can pass in web application context. You can pass in a single controller that should be used or configures. You can do all sorts of things here. I like to use the standalone setup and then just inject the repository under test. So I'll say private customer REST controller, and we'll say this dot customer REST controller, and then we need to do the same kind of setup that we did before, the mocking of the data tier, right? So let's go to the test from before and just borrow this bit here, and we're going to mock out. We're going to use a mock bean for the customer repository. So we'll go to our base class. Okay. and we'll use a @mockbean private customer repository. Very good. So there's our basic setup, our basic tests, and now we can run this code one more time. Or we can't run it actually. We have to run the code on the by running the compiler, right? So we go to the command line here, and we'll do maven clean install. That's more than enough. And in the meantime, we don't actually need this test. I wrote this test, but it turns out it's pointless. So let's get rid of that, and we'll start that compilation again. Maven clean install. Okay. So we ran the test. We didn't give our base class enough information for it to find the Spring application context. So we go back to our base class here, and we say that the class that it should use is the customer service application class. Go back here again. All right, looks like it's all right. So that's our contract. Now we can, again, we should prove the negative. Let's go back to the code here and change Jane to Janet. Do a maven clean install again. And you can see that it failed. And if you look at what happened, there's a test here that is an error, contract verifier test. So if you go to that, cat contract verifier test, or cat target, well here, cd target find iname contract verifier test, right? And we look at the last one, grep java cat grep java. Okay, so cat this one, and you can see that it's actually a test that was generated for us, contract verifier test. It extends the base class, and each test method corresponds to a contract. You can have 1 or 10 or 1,000 contracts that describe certain scenarios, certain interactions. All the stuff that you would expect to be here is here, right? So it's saying that we're expecting a response to come back that has a status code equal to 200. The headers are equal to the following. And we're using JSON path to interrogate the structure of the object that comes back from the service. So this is basically testing exactly what we tested before. It's exactly the same thing as what we tested in our previous test. It's just that it's done for us automatically, and we get that for free. But that would be interesting in of itself, because I think this is actually a fair bit easier to understand and read than the test code that I wrote. But this actually has another much more promising benefit, which is that I can now export these contracts. So let's go ahead and fix our test and make sure that things work as we expect. Okay, so Jane will be Jane. We'll do a maven clean install one more time. Maven clean install. All right, so now we've installed everything and everything is green. You can see here that there's been 3 installations: installing customer service snapshot jar, installing customer service snapshot POM, and finally, this is where it gets interesting, installing customer service snapshot stubs.jar. The stubs.jar is the artifact of the plugin that we're using, the Maven plugin for Spring Cloud Contract. The stub contains a JSON document. So if we go here, jar xvf customer service stub.jar, and you can see meta inf com example customer service mappings cat should return all customers.json. This is the native configuration file format for WireMock. So we've encoded, we've captured the contract that you provided, that we provided, and we've used that to turn it into a WireMock document, which we can then feed into well, anything that supports WireMock, really. So we can use that in the client to stand up a fake API that looks and acts like the API that we described in our DSL. So let's do that. We can go to our client now, over here, and go back to our build. And remember, in our build, we've already got Spring Cloud Starter Contract Stub Runner. So we can go here to our test, and all we want to do is use the stub runner to stand up a fake API. So we don't need WireMock anymore, right? We can actually, I mean, we could use JSON, but we don't actually need that. So what we need is auto-configured stub runner. And our job now is to specify to the stub runner where to find the stub definition that we need in order for us to be able to run this test. So let's comment out all the bits we don't need. We're going to say IDs equal and work offline equals true. Work offline means it's going to look for the stubs in the local M2 repository, not just in Maven Central or Artifactory or whatever other repositories you've got in your environment. And the IDs, that's the Maven coordinates, the Maven style coordinates or the IV coordinates or whatever, you know, the syntax for resolving that particular definition, that stub jar that we just created. So it's going to be com example colon customer hyphen service colon, and then we're supposed to provide a version. Well, of course, by definition, what we want as a client is to get the latest successfully deployed and produced stub definition. So if that test hadn't passed, then we wouldn't have been able to run Maven clean install. You can imagine doing Maven clean deploy in a real thing, but suffice it to say we have it on our local M2 repository, and either way, whether it's deployed in some other repository or a local one, we want to make sure that we always have the latest and greatest stub definition, because that represents the code that's in production, presumably, right? If I've Maven clean deployed my API, then I've hopefully, if you're doing continuous delivery, also deployed that into production, and I want to make sure that my client matches whatever is in production. So I'm going to say plus, that means the latest one, and then I'm going to tell it to run this service on a port 8081, right? And that matches the reality of what we're trying to do here, right? We're trying to say when the client calls HTTP localhost 8081/customers, we want some data to come back, all right? So that should be okay. We don't need this anymore. We're no longer trying to serialize the data ourselves. Now let's just try it. Let's see what happens. So run the customer client test. Now I'm expecting something to break. Let's see what we got. There we go. So the difference, the field in the client is different from the field in the service. We have surname in the client, and in the real thing in the service we have name. So we know that one of these is not valid. It's never been valid. But our tests were green, you might say, you might proclaim. And yes, they were green, but they didn't reflect the reality of the situation. The only way we could have caught that before was to do a proper integration test. And yes, we have cloud computing technologies, and yeah, Cloud Foundry has a great reactive Java client that you can use to, with Java code, deploy all your applications, stand them up, scale them, etc. But even that will take a minute, right? You don't want to be on the hook for that. So much better to find this kind of stuff out really quickly. So now let's run this test one more time. Let's see that that works. Oh yeah, get name. Okay. Hey, look at that, it worked, huh? So we know that it worked in catching the integration issues because it wouldn't have succeeded that first time. And we know that if the producer changes their API in some way that breaks our client, we will capture that because we will always consume the latest and greatest stub definitions, right? So that is very convenient, and this helps this means that it's easy for us to write code that is quick, right? You can see that test ran in 137 milliseconds. It's quick, it's concise. Actually, this is less code, less cognitive overhead than the other thing. And most importantly, it's scalable, right? So I can actually do this for all of my services. All my services can use contracts, and in so doing, I'm no longer required as a client to deploy every single service. I can just consume the contract, and I know that that is as good as the service because it's the same tests that the producer of the service is using to validate its own API. So, the producer is running the contract and using that as a test harness, and we're using the contract as a test harness. It's the same contract, right? Now, of course, there's some poor slubs out there who aren't using Spring, and I've heard about these. I understand that those people exist. So there is, of course, great support for running this, for using these stub definitions outside of a Spring environment. It's so convenient just to be able to say auto-configure stub runner, and then for the lifetime of your test to have all the stubs in this artifact stood up and exposed for you on a certain port. But that said, maybe you're an iPhone developer, maybe you're an Android developer, an HTML5 developer, and you don't want to have to learn how to Maven clean install and deploy Java services anyway at all, right? So for that, you can still take advantage of these stubs. We can go to our, we can see the stubs. We've seen that they're already there, right? So let's now go to the desktop, and you can use what's called the stub runner boot jar, and I happen to have a version of it downloaded So I'm going to go to the directory here, and I've got stub-runner boot jar right there. And the syntax is easy. You say java -jar stub-runner boot, and you say stub-runner.ids equals com.example customer-service plus 8081, and you say stub-runner.work-offline equals true, and then you start it up. Just as simple as we did it before, right? So now this should start on port 8081, localhost 8081 customers, and there's our data, our actual data that is being driven by that stub. And we can just, as long as we know the coordinates and we can pass that jar around, nobody else needs to know anything else. They don't need to deploy our database on your services. They don't need to wait. They don't have to have their own Cloud Foundry cluster or space or whatever. They can just test locally, iterate quickly, and develop. All right. It's worth understanding that while we've looked at how to test an API, a REST API using Spring Cloud Contract, there's a number of other possibilities. You can use Spring Cloud Contract to test messaging-based microservices using Spring Cloud Stream or Spring Integration or Camel. You can use it to mock out your service registry. So imagine in all your Spring Cloud code where you have the discovery client, you've got Spring Cloud Contract-based services or stubs that are being referenced by a mock service registry. So now you can load balance across your services that are actually themselves just stubs. You don't have to deploy the real thing. So there's a lot of options beyond what we've shown here. And indeed, there's a whole other workflow called consumer-driven contracts where you actually end up, as a client, you end up driving the evolution of the API. In this case, we did that kind of, but there's a whole approach that you can see to this. So a lot of benefits to using Spring Cloud Contract. And with that, my friends, thanks very much for watching, and we'll see you next time.